let's code some things out. What I'm going to do in our code is to code out just this first 3 levels, okay? Since the 4th level you can use a tool, I'm not going to do that, okay? I'm just going to code out these first 3 levels so that you can have a base example that you can, create your own examples in the future, and you can base yourself from. Okay, so let's get this started with. So the first thing I'll do here is to close the extra tabs we opened due to our technical explanations. So I'll just close this for here and let this one open so that we can, whenever we are coding, to understand which phase we are at. Okay, so the first thing I would like to tell you is that for this purpose, we are going to use Visual Studio Code, and we will need to use something called Plant UML. Okay, so if you come here and we search for Plant UML, okay, this is the thing we need to have, okay, installed in our Visual Studio Code. Okay, also, Plant UML, to properly work, it needs some dependencies. Okay, so if we go back to our browser, and if you go to Plant UML's website and you click on Getting Started, you'll see that it has 2 dependencies, a dependency on Java and a dependency on GraphViz. Okay, so I personally am using this locally. Okay, but one of the things you can do is to enable Docker. So you can use Docker and you don't have to worry about any of this nonsense, okay? Personally, I'm using this locally, so I have Java and GraphViz installed. So please be aware that you need to have those installed before you go on, okay? And another thing you need to understand about Plant UML is that you need to have the syntax that you will enable when you're creating diagram as code, okay, which is what we are going to do. We are going to code our diagrams. And you need to understand the kind of syntax you're going to write. And to do so, you can use Plant UML's C4 notation, let's say, okay? Of course, this is standard C4 notation, but nevertheless, they have their own Git repository, okay, where they have here all of their code for the syntax and for the components. Okay, so if you take a look here, they have a bunch of things, and there's a section down below here which is called supported diagram types, where you can see the kind of syntax that you can work with. Okay, I know this may seem a bit complicated at first, but once you see some practical examples, it will be easy to understand. Okay, so yeah, so let's just start. Okay, let's just start creating our first diagrams so that we can understand what we are doing. Okay, so one of the things we need to do, okay, besides this prerequisite of having Plant UML actually working on, is to create our Plant UML files. Okay, so let's just start and create our own Plant UML files. And to do so, okay, let's first create our context diagram. Okay, so we can have a prefix called 1 just for us to understand that this is the first level of diagrams we are creating. Okay, so 1, and let's call this context diagram. Okay, context diagram, and the extension is PUML. Okay, so Plant UML. Okay, so there's a bit of notation you need to understand. Okay, the first thing is that whenever you start this UML, you need to have starting and ending tags. They're not tags, but you'll see in a second. So you need to have a tag called start UML, okay, to denote that you're actually starting your UML diagram, and you need to have an end UML to denote that you're actually ending the diagram. Okay. One of the things that you'll see that comes with PlantUML is a preview. So if you click Ctrl Shift P, that's at least what works in my keyboard, you'll actually see if I search for PlantUML, I have this preview diagram, and you can actually see the result of the diagram you're working with. Okay, so one of the things you'll see is that this preview is quite slow, so sometimes bear in mind this actually takes time, at least for me. So yeah, so have that in mind. Okay, so one of the things you need to do as well is to include the notation that your diagram is going to use. In this case, I'm creating a context diagram. Therefore, I need to include the notation for this diagram. And because this is quite verbose, at least lots of letters, so I'm just going to copy paste what I have. What you need to do or indicate to this to the UML file is, hey, include this context thing here. Okay, and we'll explore a bit more the repository in a second, but this is what you need to do. Okay, tell the script that, hey, import this the notation here. Okay, one of the things that you can do with this diagram is to give it a title. Okay, so there's a title construct here, and you can call it, let's call it my e-commerce. Okay, let's build the microservice e-commerce app. Very, very simple. Okay, no crazy things here, but this is what we're going to do. Okay, so title my e-commerce. Okay, and as you can see here, it takes a time to actually do something useful, so I told you this was slow. Okay, now one of the things that you normally do in this kind of diagrams is to represent the user of the system. Okay, so who actually uses the system, and for that you have a person construct. Okay, so this person construct, it allows you to pass in some arguments to it. The first one is what they call an alias, so like an internal ID. We can call this person. Okay, okay. The second one is a label for that construct. Okay, so as you can see here, the person has already showed up. So here is a label, so we'll call this client. Okay, and the third one is an optional description, so let's just put this as e-commerce user. Okay, or in this case we can put it as user, that's okay. So as you can see here, we have the person construct, the label, and the description. Okay, how do I know all of this? So if you go back to their GitHub, you'll actually see that this is the person construct. The first thing is an alias, the second is a label, and this is an optional description. Okay, so each construct has the number of parameters that it has, and you need to understand what they are. So I highly advise you to take a look at whatever they have written here in their GitHub README. Okay, and perhaps also on their documentation, of course, as well. Nevertheless, let's come back to our diagram. Okay, we normally start by introducing this person construct, okay, which is the person, the user that uses our system. Okay, and one of the things that we normally do as well is to define the system itself that we are operating. Okay, so for that we have a system construct. Okay, and as I told you, the first thing is normally an alias, so let's call this e-commerce system. Okay, so the label can be e-commerce system, and we can leave the description empty. Okay, we don't need the description. Okay, so as you can see here, it automatically it creates a system for us. Okay, So our system is the system that you are designing, or the system you want to showcase people that you are developing. Okay, so this is our main thing, the thing of interest here. Okay. Now, normally our systems, they have external components that they use, that are dependencies. For example, as I said, an external payment provider. You can have, for example, some observability platforms that you enable, and so on. Okay, so we have also a construct that allows us to represent those concerns. And the construct is system underscore ext, or system external, I suppose. So we are going to create two external systems that our system uses or enables. Okay, the first one is going to be an observability platform, let's say. Observability. We can give this a label of observability platform. Okay, so it doesn't matter, just give a meaningful name for this external system. Okay, we can then create a new external system. Let's call it payment gateway. Okay, and we can put a nice label here called payment gateway. Okay, and so having written those, this is the system we are creating, the system we are developing. But now what we are missing is the relationship between those building blocks. So my client should use my system, and my system should enable this two external system, as you would see, for example, here on the high level diagrams. Okay, you see arrows pointing outwards. Okay, so you actually see the relationships. Okay, and this is what we are going to do right now. We are going to configure the relationships, and to configure relationships you have the rel construct. Rel, I suppose, as in relationship. So you should have the internal aliases now here. So we first want to configure a relationship between our client and our e-commerce platform. So the internal alias for the client is person. So let's just put here person. The outgoing dependency, let's say, it's our e-commerce system. So we can put this here. And you'll soon see that there's an arrow that will point from person to e-commerce. Okay, and whatever comes next is some descriptions. Let's say, so if we go to the GitHub and you see the rel construct. Okay, if you look for the rel construct, you see here that we have a label and an optional technology. Okay, so one of the things that you'll see people do is that they'll put here uses. Okay, since this is the label, and here the technology, let's say HTTPS. Okay, so and you'll see clearly that, okay, this uses the interaction happens via HTTPS. Okay. And now we can do the same things for the other components. Okay, let me duplicate this. One relationship is between our e-commerce system and our observability platform. And another one is between our e-commerce and our payment gateway. Okay, so by doing this, you will soon see some arrows pointing from our e-commerce system towards our external concerns. Okay, so, and by doing this via code, okay, you can see clearly what happens. I actually think the syntax is pretty explicit, so you can clearly see and understand what's going on. and by using the preview you can also see explicitly what's going on and you can understand things better. Okay, and this concludes our first diagram, which is our context diagram. Okay, so now we've finished our context diagram. Now let's create our container diagram. Okay, so let's create another file. Okay, let's create another file. Let's call it 2_container _ diagram .puml. Okay, so the same constraints as I said before apply, which means that we need to, and let me just copy this. So you need to have this initial and ending constructs here to showcase that, okay, this is the beginning and this is the end of my diagram. And also you need to have the include statement. Now, one of the things you should understand is that this includes need to change, because now it needs to be not the context but the container. So just saw that the container keyword just changed here. Okay, now things are going to be a bit more verbose right now in terms of the components we'll create and enable. Okay, so we can still keep the title, we can still keep the we can still keep the title, but we need to refactor the system so that we can zoom in on it. Okay, so let me just remove this. Let me keep the payment gateway, okay, for now, but I'll remove the observability one just to make this diagram simpler. So this means that we can also delete this one. Okay, and we can have this payment gateway here at the top just for organizational purposes. Okay, and now let's remove this. Okay, now what we'll do is we will go into more detail as far as what's inside our system. Okay, so one of the things we need to do here is to create the boundary, so the zoom in action where you zoom in into our system. Okay, and you can do that by having the system underscore boundary construct. Okay, you can open and close those brackets. Okay, now you need to have an internal alias for it, so e-commerce, and also I suppose that's a label, okay, that you need to have here. Okay, we can actually confirm this again by going to their GitHub and just looking at system boundary, the construct for system boundary, and you will see, let's search for it, you see that alias and label. Okay, so you'll actually see what are the parameters that this system boundary construct enables. Okay, now one of the things you need to do now is to create your containers. Remember, this is the container diagram. Okay, so we will have here a couple of things. Okay, I told you we're building a microservice application, just very simple, very basic one, just to have an excuse to create multiple containers. So let's create a container for a web app, okay, or SPA, and 3 containers, 1 container for a catalog microservice, 1 container for an order microservice, and another container for the payments. Okay, so let's do that. Okay, now as I said, we want to create a container for our SPA, so container. We have the container construct. This allows us to define and specify a container. Okay, so we pass in an internal alias, so let's call it SPA. Okay, a label. Okay, so we can call this SPA React. Oh, okay. And here we can also use the technology. So as I just said in a label, React. Okay. Then we have, I suppose, an optional description. Okay, we will not use that optional description. Okay. Now, to confirm whatever I'm saying, you can always come here as I was always saying this, but you can also always come here and see, okay, is the fourth parameter an optional description? As you can see, yes. So, okay, so you can always recur to the constructs specified here, okay? Now, we just created a container for our system, okay? Now let's create a couple more containers. As I told you, we would have 3 microservices, okay? We would have a catalog service, okay? And let's call this here catalog microservice. Okay, and the tag can be .NET, for example. Another microservice we can have is order. Okay, I'm not saying that this actually makes sense semantically speaking, but bear in mind, keep going. Okay, the technology can be .NET as well. Okay. No, this is a label. Sorry. So this is our order microservice, and now technology.NET. Okay. And last but surely not least, we have our payment service. Okay, we can call this payment service. Okay, and this payment service will be like an anti-corruption layer for our external payment gateway. Okay, so those will connect. Okay, that's why I kept it. Okay, so this service or anti-corruption layer can be on .NET as well. Okay. Now a couple of things we need to understand. So we created our containers, and as you can see here at the top, we have the indication that this is a container. Okay. Now one of the things we need to do here is to specify the databases that our services will use. Okay, and to do so, there's a construct called containerdb, which will allow you to create a database for the containers. Okay, so let's call this catalogdb, so database for our catalog microservice. Okay, I can call this catalogdb, and let me use a MySQL. Okay. Okay. Now we also need to create a database for the other one. So since we have 3, let me just duplicate this. So another one that we need to have is our order DB, and we also need to have our payment DB. Okay. Now I also need to change this order DB, payment DB, and I can have here a MongoDB. Okay. Some folks also like to use here some images to specify the technologies that you are enabling, and if you go to their docs, you will see that they have this here somewhere. So for example, here they have Angular, Java, and SQL Server, so you can see the logos here. Okay, so you can do those kind of things. I personally don't want to do this right now, but beware that you can. Okay, so having created the containers and having creating the databases, now it's time to actually create the relationships. Okay, so as we saw previously, we have a relationship between the components, and now we are going to link each service with their corresponding database, and also, for example, the React app will connect with the catalog microservice only. Let's assume that that's a real case, and we also have the payment service communicating with the external gateway, and then you have the client connecting with the React app. Okay, lots of relationships. Let's build one by one. So the first one, we are going to build this client using our SPA. Okay, as I told you before, there's a rel construct here. So the first thing that you have to use is person. Okay, since person is our construct. The end is our SPA React, which is we call SPA. And we can use the users label and the technology HTTPS. Okay, so and now you'll see that our client is using our SPA. Okay. Now what I'm going to do is to build a relationship between each service and their corresponding databases. Okay. So let me copy this relationship construct. Now from the catalog service to the catalog DB. Okay. We can also use the users label, and in the technology we can use, I don't know, EF core. Let's assume that we are using an ORM to help us to connect and to manage the interactions with our database. Okay. If you were using Java, it would be something like GDBC. Hope I'm pronouncing that correctly, and so on. Okay, .NET also has Dapper, so you can specify here in a lower detail the kind of technology you are enabling. Okay, that can be language specific in this case. Okay, so the other relationships that we are going to create is from the order service to the order DB. And we can use EF core as well, and from the payment service to the payment DB, and we can use also EF core. We can specify here Mongo package, okay, that .NET provides, but doesn't matter what actually we write here. You just want to make sure that you understand that you can specify here the technology that you can enable. Okay. Now, another thing we said we were going to do is to connect the payment service with the external gateway. And that's what we're going to do. So let me take the payment service. Here, I have it here. Let me connect it with the payment gateway. Okay, and I can use, let's assume we use HTTPS. Okay. So we can have something crazy like that. Okay. Uses HTTPS. Okay, as you can see here. Now the only thing that's missing is a connection between our React app and, let's say, our catalog microservice. Let's build that relationship. So the initial service is the React app, which we know it's called SPA internally because we give it an alias. Now the destination, which we said was the catalog microservice, we call it catalog service, the internal alias, and we can still have the users HTTPS. Okay. So as you can see here, our React app interacts only with this catalog, but now we may want to add relationships between this and this and this and this. So I'll actually leave those for you, okay? But it should be straightforward according to this. The only thing I'm going to do right now is to actually show you how you can use asynchronous communication, because sometimes our services, they don't use this synchronous communication between themselves. Sometimes they use a message broker, for example. And in this case, I want to show you how we can enable such asynchronous communication. Okay. let's assume, for simplicity's sake, that our catalog microservice communicates asynchronously with the order microservice. Okay. Now, one thing you need to understand is that in order to import that async thingy that you need to enable here, you can do something like this, okay? And what you're doing here by using the add rel tag construct is that you are creating a tag called async and giving it a dashed line. So as you probably know, or if you don't know, that's okay. Whenever you are using synchronous communication, normally on the diagrams use this straight line here. But whenever you're using asynchronous communication, normally use a dashed line to represent the asynchronous communication. Okay, that's why here we are going with this default approach that states, okay, whenever I use this async tag, please use this style for my line. And again, if you go to the documentation, you'll see what kind of extra things you can enable here, okay? So let's now create this asynchronous relationship. Again, we use the relationship construct, okay? I told you I want to connect the catalog with order, therefore the first one here should be the catalog service alias. The end one should be the order microservice, so order service. Okay. Now, instead of being HTTPS, let's assume we are using a queue or a topic. Okay. Now, if you don't do anything else, what happens is that you will have this this straight line, which indicates that, okay, this is synchronous communication. But if you come here and use tags equals async, what happens is that internally it will recognize this tag async and recognize that the style is dashed. And if you noticed, now the line is dashed instead of straight, okay, to indicate that, okay, this is an asynchronous communication, okay? And just to make the payment service happy and not sad because it's alone, let's make the catalog microservice also communicate with this one. No, let's put the order microservice communicating with this one, okay? So order service will communicate with the payment service asynchronously, okay? So now every service somehow communicates, even if it's asynchronously, okay? So as you can see here, our catalog service can use a queue to communicate with order and order with payment. This can be a saga, for example, representing an asynchronous saga, okay? But anyway, you can see now that the level of detail when compared to this one, which will take a while, and I'm sorry for that, is much more, okay? You have much more detail than this diagram, which is just high level. Okay, I'm creating an e-commerce system and that's it. Okay, if you zoom in on this e-commerce system, you'll see here that we just zoomed in much more detail. I can see the individual building blocks, aka containers, and you get a more technical sense of what's going on. Okay. Now, what we are going to do is to explore the component diagram. Okay, so we are going to choose one of these components, okay, and zoom in into that component. So the component that we are going to zoom in is the catalog microservice. Okay, so it's going to be a very simple component diagram. Okay, the goal is for it to be simple so that you can get creative, but you'll still get the basic knowledge. Okay, so let's create a new file here called level 3 called component diagram.py. PUML. Okay. Again, and let me copy this one because it's simpler. We need the start and end constructs. Okay. And as I told you before, we need to adjust the include with the kind of diagram we are building. Right now, I'm building a component diagram, therefore I need to include the component here. Okay, so I need to explicitly tell that I'm including the component. Okay. Now, as I told you, we are going to zoom in into a container and we'll see each individual components. Okay. Now, here we are going to abandon the client since we are just zooming in into a component. So let's see our farewells for now for our person. Okay. Okay. I mean, I can just start from scratch. Probably the best. Okay. Just leave the title. So the thing I need to have is our container for the SPA. Okay. Let's have the container for the SPA here. React SPA. Okay. And since I am working on the catalog service, let's still have the catalog DB as well. Okay. Since our service will interact with the database. And now we need a construct that serves as the zoom in action in a container. In the container case, it was the system boundary. Okay. And here is the container boundary. Okay, so the boundary where you zoom in into a container. So the construct is called container boundary. Okay, let's open and close our braces, curly braces. So we can call this API, okay, or just catalog API. This is our internal alias, and we can give this a label of, let's call it catalog microservice container. Okay, so we are zooming in into our container. Okay, our container, let's say our container has two controllers. Okay, just to make this very simple, it has a catalog controller where you can see the catalog, and has a favorites controller, which is when you click on heart or you really like something and you want to put it as favorites. So this kind of interactions, okay, just for simplicity's sake. Okay, now as you can see here on the right side, you already created the boundary for the container. Okay, so what we'll do here is we'll create two components. Okay, the catalog controller component and the favorites controller component. Both of them will interact with our catalog DB. Okay, and our SPA, of course, will interact with both the components. So to create a component, you have the component construct here. Okay, and it, as always, the first parameter normally is the internal alias, so sign in. So not sign in, sorry, the catalog controller. Okay, we can have a label for this called catalog controller. Okay, optional description, we will skip that to make this simpler. And let's create another component called favorites controller. Okay, favorites controller. Okay, so you will see here now both components being created. Okay, now what we'll do is to actually, let me do something just to make this more verbose and to make you guys see this in a higher complexity. Let us add a couple more things. Okay, I made a mistake. This is not the description, this is rather the technology. Okay, let's call this MVC controller, And let's add a description here. Okay, so interactions with the catalog. Okay, just to make it the use case more interesting. Okay, here the favorites controller, let's assume, okay, this is a minimal API, this is .NET minimal API. Okay, and make items description, make items in the catalog belong closer to your heart. Okay, so that you can see this thing getting a bit complex. Okay, and as you can see here, you have the indication that this is a component, the component label name, the technology it uses, and the description. Okay, now one of the things I would like to do is to actually create a relationship between these components and the database. Okay, because let's assume each of these components interacts with the database. Okay, so let's use the relationship construct, which we know is the construct we use to create relationship between two, let's call it entities or basic blocks. Okay, in this case, I want to create a relationship between my catalog controller, okay, and my catalog DB. And my label is writes and reads from, and the technology can be EF Core. Okay, and I want the same relationship but from the favorites controller point of view. Okay, so you'll see in a second the arrow pointing from the favorites controller, okay, to the catalog DB. Okay, now we also need the relationship between the SPA and the individual controllers. Okay, let's create that in this context, higher level context. So we want to use the rel construct. Okay, again from our SPA, remember, internal alias, to our catalog controller. Okay, here is the label, so uses, and here is the tag, so HTTPS, and same from SPA to the favorites control. Okay, and so you'll see in a second the arrows going from the SPA to the SPA container, okay, to each individual controller. Now, of course, I placed these relationships in the outside context. What would happen if I were to place them internally? They would still work. Okay, so just to prove to you that I'm not lying, I'm going to close the preview and just preview this again. So the relationships will still work. Okay, I just created them in the higher level context just because I specified the SPA container on that higher level context. Okay, so and by doing so, you can see now the full relationship between a container and another container, but in this case the internal components from that container. Okay, hopefully that was clear for you guys. Okay, now one of the things that I told you I was going to speak about is exploring in more detail the GitHub from Plant2ML. Okay, hopefully this exercise allowed you to see, going from a higher level diagram, so high level big picture diagram, understanding the system you're building, zooming in on this system, okay, and seeing the individual building blocks from that system, okay, which we called containers, seeing the interactions between the containers, their dependencies, and so on, and going into more detail in a single container. Okay, so we decided to zoom in on the catalog microservice, and we saw that that catalog microservice had, in this case, two components. Of course, it could have more, but in this case, a catalog controller and a favorites controller. Okay, and what are their interactions with the database? In this case, could be other components, as you saw in the sample in the documentation. Okay. Speaking of samples, okay, this source code will be available to you. Okay, I'll put this in the description of the video, as well as all the documentation links I showed here during my theoretical assessment. But now let me show you the GitHub from PlentyUML C4. Okay, because it has some very nice samples as well of more complex diagrams. So if you go to their GitHub, they have here a samples folder here. Okay. Again, all of these links will be provided to you on the video description. Okay. And you can see here that you have lots of other samples, okay, for multiple diagrams. Okay. In this case, you have container diagram, you have your component diagram, you have context diagram, and so on. Okay. Let me open a context diagram. Okay, let me see if we can have something interesting to showcase in the preview. Okay, so let's see how they built this sample. Okay, it will take a while. Okay, now you can see here that they also have an approach like ours, and they have a legend here as well. So I told you that things can get creative when you are building things using C4. Okay, now let's preview a container diagram. Okay, so this is a big one as well. Let's see how this looks like from their end as well. Okay, they have fulfilled all the descriptions, so the diagram may look a bit bulky. Okay, but the intention is the same, guys. Okay, the intention is to showcase, to zoom in, showcase architecture and building blocks. Okay, and as you can see here, they also have the asynchronous tag here as well. Okay, it's same as we've done before. Okay, but more complex. Okay, ours was a bit more simple, but you get the point. Okay, the point is that you can get creative when you use C4. Okay, and I advise you to take a look at each one of these samples and see how they look like and so on. And also here you can see other samples from diagrams that we haven't seen. Okay, deployment diagrams, dynamic diagrams, we didn't go through them. Okay, but they also have here very interesting samples on that matter also. Okay, so let's try to sum up what we've seen today about C4 and pros and cons of it. Okay, so coming back to the basics, we saw that C4 could be used for documenting our software architecture in a more visual way. Okay, it had 4 levels. Context level was the first one. It had where you would see your system in the big picture, in the high level overview. Okay, here. Then you had the second level, which was the container level, which you zoomed in into a specific into your system, and you would see the individual building blocks. Okay, and then you chose one of those building blocks, which we call containers, and saw each individual component in level 3, which we approached the component diagram. Okay, and then we saw each individual component related to each other, related to databases and so on, and then you zoom in into one of those components and you can see the internal code. We actually haven't gone to that level because, as we said, they're not the point of this video, because you can also have IDEs generating this for you, but that's the point. In my opinion, C4 is actually quite intuitive. Of course, it's code driven. Okay, there might be other plugins that people use that may alleviate you with the burden of coding. Okay, I've seen some of them, although I didn't bring here today, but I remember seeing um, C4 diagrams being enabled like a drag and drop. Okay, and I wanted to show you the code just to explain to you the process, the thought process of how C4 actually works behind the scenes. I think it's quite intuitive. If you are doing this by code, it will take you a bit of time, okay, to actually do the code, uh, to actually have the diagram as code. Okay, or you can decide to use an external tool that uses the C4 annotations as well. Okay, up to you. The problem with any new tooling is that you actually need to learn it, but I personally don't think that the learning curve for C4 is actually that steep. Okay, I think you can quite well understand the purpose of C4 and how you can enable C4. Okay, but overall, I think it's a very nice project. The intentions are very good, and I highly recommend you to use it when you actually see the need for it. And overall, very nice work from the creator. Okay, so that's it for this video. Thank you so much for watching, and hopefully I'll see you in the next one.